All right, class. So this is going to be our video for section 3.2 dealing with synthetic division. So let's just do a quick recap of how we do divide by hand using long division. So if it's had it set up like this, I mean, this is the same thing as 19 divided by 5. And so we'd write it this way using long division. So first thing we're trying to figure out, well, can 5 go into 1? It cannot. And so then we extend it. Can 5 go into 19? It can, and at most it can go in 3 times. And so with long division, you would multiply 3 times 5 to get 15, and then we subtract as we go down. So 19 minus 15 would equal 4, and so we have a remainder of 4 because 5 doesn't go evenly into 19. But if we think of this, we can still get 19 if we do 5 times 3 plus our remainder of 4. So that remainder is important for this one. Okay, so some terminology. The piece on top is called the quotient. Outside of my division symbol, that's the divisor. And then underneath my division symbol is the dividend. Okay, so again, the outcome of a division problem, we can actually write it with multiplication, just like we did in that warm-up where it was 5 times 3 plus 4. In this case, if we wanted to get 24, that would be 4 times our quotient, our q of x, which is 6, plus any remainder. Well, 4 goes into 24 nicely, it goes in there 6 times, so this remainder would be 0. So that's writing any division problem as multiplication. We can also use this with polynomials. So if we want to do any sort of polynomial division, what we are going to focus on is synthetic division. So synthetic division is what we're going to use to divide any polynomial by another polynomial, and this has to be in the form of x minus k. Or say it again, must be in that form of x minus k. So it has to be a binomial out front here as our divisor. It has to be a binomial. And that x minus is important. All right, so there's some steps that you need to follow. And so these steps that we're going to look for is, okay, how can we use synthetic division? So write only the coefficients of the polynomial in decreasing powers. And if you have any coefficients that aren't there, say we had x cubed, now we'll go 3x to the fifth plus 4x squared plus 3 or something like that. We actually would want to write this where we take into account all of them. So use a 0 as a coefficient for any missing powers. So this is 3x to the fifth plus 0x to the fourth. We want to account for that fourth plus 0x cubed plus 4x squared plus 3. So adding in these zeros are important. We need these placeholders. All right, this number k is written up in the press box. And we'll get to what that press box means here in a minute. Okay, and again, this x minus k standard form is x minus. So really, this one, I have a positive k value. If it was some x plus k, well, really, that would be x minus a negative k. And so my k in that one would be a negative k value. All right, so back to our bullet point here. This number k is written up in the press box. And remember, it must be in that form of x minus k, and we want to pay attention to that sign on k. And we'll do a couple examples of it. All right, so here we go. Use synthetic division to divide these two polynomials. All right, so really this is saying x plus 2, and it's going to be divided from 5x cubed minus 6x squared minus 28x minus 2. So this right here, x plus 2, remember we're looking for that x minus k value. So really x plus 2, this is really x minus a negative 2. So I'm going to put negative 2 up here in my press box. So I'm going to make this negative 2 right up here. And then from this, all I'm going to do is write down the coefficients of my polynomial. And this one, I went x cubed, x squared, x to the first, and x to the 0. So all of them are accounted for. So that's good. But I'm only going to write down those coefficients. So 5, negative 6, negative 28, and negative 2. When we are doing synthetic division, we are always going to add vertically. Remember when we did long division, we would subtract vertically. Synthetic division is different. We want to add vertically. First thing we're going to do is simply bring this 5 down. So there's no addition, there's nothing going on. To determine what this spot is here under the negative 6, we're going to take 5 times negative 2 and put that product in this spot. So that would be a negative 10. And then again, we are going to add vertically. So negative 6 plus a negative 10 is negative 16. Now we're going to take negative 16 and multiply it by negative 2. Put that product over here, which becomes a positive 32. Negative 28 plus 32 is a positive 4. Take 4, multiply it up to the press box, put that product here, becomes a negative 8. Add these two together, we get negative 10. And with synthetic division, this last term that you find here is always the remainder. Because you can have that last piece there be 0. But in this one, we actually do have a remainder going on. These first 3 terms make our polynomial. And so if we're going to work, sometimes you can think of this as working backwards. 4 is my constant. Negative 16 would be with x, and 5 would be an x squared. So I'm going to rebuild my polynomial, and this last negative 10 becomes my remainder. Now, we always want to work with our remainder and think of it always as the remainder over or divided by the divisor is how we're going to represent our remainder. And again, this x plus 2, this is the divisor. Same thing right here. This is the divisor. And so we'd have 5x squared minus 16x plus 4. And then we're going to add to this a negative 10 all over our divisor of x plus 2. Okay, so this would be using synthetic division where we end up. So if I wanted to get back to this original spot, okay, so I'm trying to say, okay, if I take this, because this is going to be one term, and I can think of it as a product. If I took this, sorry, I'm going to have a bunch of lines going on here. We'll go in green. So this piece right here multiplied with this will equal that. Just like we had on that very first problem when we had 4 going into 24, and then we had 6. If I take these two and multiply them together, I end up with 24. So the same thing now. These two multiplied together will get me what's under this division sign. Okay. All right, let's do another thing that deals with what's called the remainder theorem. So this says if the polynomial f of x is divided by x minus k, then the remainder is simply equal to f of k. So we identify what k is, put that into our equation, evaluate, and that's our remainder every single time. Okay, so how does that play out? So use the remainder theorem to find f of negative 3. So f of negative 3, color. So f of negative 3 would simply be a negative of negative 3 raised to the fourth power plus 3 times negative 3 squared minus 4 times negative 3 minus 5. Work this out, end up with a negative 81 plus 27 plus 12 minus 5. All of that ends up being negative 47. So the remainder is negative 47. Next thing we're going to talk about are potential zeros of polynomial functions. And so again, what does it mean to be a zero of a function? So a zero of a function is simply that x-intercept where it's crossing the x-axis, or we can think of it whenever y is equal to 0, we're not off of the x-axis vertically at all. So that's a zero of a function. We can use the remainder theorem to determine if a value of k is actually 0. So to do this, we are going to evaluate f of k, meaning we're simply going to substitute the value of k into that function. And after we do that substitution, if we get an answer of 0, then k is a 0 of that function. But if f of k is not equal to 0, then k is not a 0 of that function. So let's use that. Let's determine, is k a 0 of the function? So the first one we're going to look at is f of x equals x cubed minus 4x squared plus 9x minus 6. And they're telling me k is equal to 1. So if I evaluate this, if I determine what f of 1 is, that's going to be 1 cubed minus 4 times 1 squared plus 9 times 1 minus 6. I work all that out, I do get 0. Okay, so therefore, yes, it is a 0. And specifically, we know the point 1 comma 0 will be an intercept. Will be an x-intercept. Okay, let's do another one. So now they say use a different polynomial, but evaluate it at negative 1. So f of negative 1 would be negative 1 to the fourth, and use your parentheses on that. If you simply put in negative 1 to the fourth in your calculator, it's going to tell you negative 1 as an output, which is false. So it's negative 1 raised to the fourth power, which is positive 1. And then we're going to have plus negative 1 squared. Again, use your parentheses so you don't mess up. Minus 3 times negative 1 plus 1. So we have 1 plus 1 plus 3 plus 1. Add all that up, we get 6. So we know now that negative 1 is not a 0. So this k equaling negative 1. So negative 1 is not a 0. But we do know that the point of negative 1 comma 6 is on the graph or on the line of the function f of x. Okay, so that was a quick recap of remainder theorem, synthetic division, and determining if we have a zero, if there's an actual k value that is a zero of the function. So start working in Math Excel 3.2, due Monday by the start of class, and then Monday we'll recap and I'll take any questions that you have.